Here are the answers for the section 6-7 homework, starting with page 239 oral. We're asked to figure out the value of n in the expression so that the trinomial is the square of a binomial. This goes back to what we were doing in chapter 4. We learned that some trinomials factor into the square of a binomial. Those trinomials were called perfect square trinomials. The general pattern that we used was a squared plus 2ab plus b squared. That factored into the square of a binomial. The point is that we want to create a perfect square trinomial. So in number 1, for this trinomial to be a perfect square trinomial, what must be the value of n? To find that value, we're going to take half of the coefficient 2, which is equal to 1, and then we're going to square the 1, which is equal to 1. And that's what the value of n has to be. N equals 1. If it was, then that would be a perfect square trinomial. It would be x squared plus 2x plus 1. And that would fit that pattern of a squared plus 2ab plus b squared. And we could then factor it as x plus 1 squared. Now we're not asked to actually do this here. What we're asked is, what's the value of n so that it is a perfect square trinomial? Let's try that with number 3. What does this number have to be so that this trinomial is a perfect square trinomial? To find the number, we're going to take half of the negative 12. That makes negative 6. Then take the negative 6 and square it. And that makes positive 36. And that's what n has to be. N has to be 36. That question's done. But again, let's pursue the reason why it's 36. Because if it was, then the trinomial would be t squared minus 12t plus 36. And this would factor as t minus 6 squared. Number 5, let's follow our same technique to figure out what the constant term is. Take half of the coefficient of the middle term. So half of negative 1. That makes negative a half. Then square the negative a half. That makes positive 1/4. And that's what the value of n has to be. Okay, this question is done. But again, let me give you a little bit of extra information on it. If n was 1/4, then our trinomial would be u squared minus u plus 1/4. And that could be factored as a binomial squared. This would be u minus a half inside there. Okay, number 7, same thing. What's n have to be? Well, what's half of negative 10? That's negative 5. Then, what is negative 5 squared? That's 25. So the n has to be 25. Number 13, state the number to add to each side of the equation to make the expression in the parentheses into a square of a binomial. Once again, we have to figure out what is this constant term so that this trinomial is a perfect square trinomial. The process for finding that is to take half of that middle coefficient, half of 8. That makes 4. Then square that 4. That makes 16. So the number that we would want to write right in that spot is plus 16. Because if we did that, then that trinomial in the parentheses is a perfect square trinomial and it can be factored. Now we know that when we have an equation that has a left side and a right side, that you can't only add a number to one side. You have to add the same number to the other side to retain balance. When we filled in a 16 in the parentheses, what did we really add to the right side of the equals? It wasn't 16, because in front of the parentheses is timesing by 3. When we put a 16 in here, 3 times 16 is 48. We've actually increased the right side by 48. So to retain balance, we would have to add 48 to the left side. And that's what answers the question. We would add 48 to both sides. It's just that on the right side, the 48 is written as a 16 with the understanding that in front of that is the timesing by 3. Now number 15, the same directions. Here is an equation, and on the right side of the equation, there is not a trinomial yet. Let's make a trinomial, and let's make it be a perfect square trinomial. So let's figure out what half of 6 is. That's 3. Then square the 3. That's 9. Let's add 9 in the parentheses in this blank spot. Now there's a trinomial on the right side of the equation, and it's a perfect square trinomial. Now when we wrote a plus 9 on the right side, we have to do something on the left side to compensate. You see how there's a negative 2 being times in front of the parentheses? Negative 2 times 9 is really negative 18. So when we wrote a 9 in here, we really have adjusted the right side by negative 18. So what we need to say is that we're going to add negative 18 to both sides. It's just that the form of the negative 18 on the right side of the equals is a 9 here, but with a negative 2 out in front. Now page 240, we're asked to graph the equation. Unlike in the last chapter, this equation is not written in the form called vertex form. Vertex form had a special pattern to it. Vertex form was y equals some number, we call it a, times x take away some number, which we called h, squared, plus some number, which we called k. And when it had this format to it, we could quickly find the vertex, it was h comma k, and then we could make a chart to get other dots to make the branches. We do not have that form. Instead, we have the start of standard form. Standard form of a quadratic equation has this basic look. Y equals some number times x squared plus some number times x plus some other number. We have this format here, where in front of x squared, we can see that a is 1. In front of the x, we can see that b is negative 4. And added on the end, we can see that c is just a 0. When we have an equation in standard form instead of vertex form, we can still find the vertex. There's a math formula that we learned in this section. The vertex is given by the formula negative b divided by 2a, comma, c minus b squared over 4a. This formula for finding the vertex came from using completing the square to change standard form into vertex form. So let's apply the formula with the numbers that we have for a, b, and c. We're still going to make an xy table because you graph parabolas by finding dots. And we're still going to make the middle row be the vertex. It's just not as fast as using h and k to get the vertex. Instead, we need to use these formulas. To get the x-coordinate of the vertex, we use the negative b over 2a. b is negative 4, so the negative of negative 4 is positive 4. a is 1, so 2 times 1 is 2, and 4 over 2 makes 2. The x-coordinate of the vertex is 2. Now let's use this c minus b squared over 4a formula to get the y-coordinate of the vertex. c is 0. b is negative 4. So b squared would be negative 4 squared, which is 16. a is a 1, so 4 times 1 is 4. 16 over 4 makes 4, and 0 minus 4 makes negative 4. The y-coordinate of the vertex is negative 4. So we still have found the vertex. It just took extra work because our equation was not in vertex form. It was in standard form. Now the rest of the technique is going to be the same. Choose a number to the left of 2, like 1, and then choose a number to the left of that, like 0. Then choose a number 1 unit to the right of 2, like a 3, and 1 unit to the right of that, a 4. Now substitute these numbers into this original equation to solve it for y. Let's start by putting in a 3. 3 squared makes 9. 4 times 3 makes 12. And 9 minus 12 is negative 3. And then this will be negative 3. If you don't believe it, you can plug in a 1 and see what you get. 1 squared makes 1. 4 times 1 makes 4. And 1 subtract 4 is negative 3. Now let's substitute a 4 in place of x. 4 squared is 16. 4 times 4 is 16. And 16 minus 16 is 0. And this is going to turn out to be 0. Now we can graph our parabola. 2 comma negative 4 is right 2 and down 4. There's the vertex. 3 comma negative 3 is here, and 1 comma negative 3 is here. Notice how those dots are mirror images. They're on the same level. Then 4 comma 0 is here, and 0 comma 0 is here. Again, these dots are mirror images of each other. Now we can draw in the curving branches. Number 3, we want to graph this equation. It goes to the second power, so it is quadratic. Is this quadratic equation in vertex form, or is it in standard form? We have to know the answer because that affects how we get the vertex. This is in standard form. The value of A is a 4. The value of B is negative 8. And the value of C is a 0. So because it is in standard form, this is how we're going to get the vertex. We're going to use the formula, negative B divided by 2A, comma, and then C minus B squared divided by 4A. Let's apply those formulas using our values for A, B, and C. And the reason we're doing that is to get dots in an XY table. Let's start with the middle row of the table because that's where you record the vertex. Okay, to get the X value figured out, we're going to use the formula negative B divided by 2A. B is negative 8. So the negative of negative 8 makes positive 8. A is 4, so 2 times 4 makes 8. And 8 divided by 8 makes a 1 right there. Now let's get the Y value of the vertex. Using this formula, C is 0. B is negative 8. So negative 8 squared makes 64. And then 4 times A, but A is 4. So 4 times 4 is 16. 64 divided by 16 makes 4, and 0 minus 4 is negative 4. If you don't want to use this formula to get the Y value of the vertex, then simply plug in 1. 1 squared makes 1. 4 times 1 makes 4. Over here, 8 times 1 makes 8, and 4 minus 8 is negative 4. Plugging in 1 into that formula gets us negative 4, the same thing we get when we use this C minus B squared over 4A formula to get the Y value. I'm going to choose 0 because it's to the left of 1, and then negative 1. Then I'm going to choose 2 because it's to the right of 1, and then 3. And I'm going to plug these numbers into our original equation to find our f of x values. I'm going to plug in 2. 2 squared is 4, and 4 times 4 is 16. Over here, 8 times 2 is 16, and 16 minus 16 is 0. This is 0, and this is 0. Now I'm going to plug in 3. 3 squared is 9. 4 times 9 is 36. Over here, 8 times 3 is 24. And 36 minus 24 makes 12. and this makes 12. Now let's graph this. The vertex is 1, negative 4. So over to 1, down to negative 4. Then we have a dot at 0, 0, and 2, 0. Then we have a dot at negative 1, 12, and 3, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 marks is right at the very top of the video screen. There's a dot here, and there's a dot here. And now we can draw in the branches. Next, number 5. This is a quadratic equation. When we graph it, it is going to be a parabola. So we know we have to find the vertex. Is this equation in vertex form, where you use the h, k, or is it in standard form, where you have an a, b, and c? It's standard form. The value of a is 1. The value of b is negative 1. And the value of c is negative 6. In standard form, when you want to find the vertex, you get the x-coordinate by using negative b divided by 2a. You get the y-coordinate by going c minus b squared over 4a. Let's make our xy table. And start with the middle row of the table, the vertex. To get the x-coordinate, we're going to use negative b over 2a. Well, b is negative 1, so the negative of negative 1 is positive 1. And a is 1, so 2 times 1 is 2. The x-coordinate is a half. Now let's get the y-coordinate by using this formula. The value of c is negative 6. The value of b is negative 1, so negative 1 squared makes 1. The value of a is 1, so 4 times 1 is 4. We have negative 6 take away 1/4. That is negative 6 and 1/4. Now let's choose something to the left of a half. I'm going to choose 0, and then I'm going to choose negative 1. And then to the right of a half, I'm going to choose 1, and then I'm going to choose 2. Let's plug these numbers in and see what we get for y, starting by putting in a 1. 1 squared makes 1, and then you'll put a 1 right here, so 1 minus 1 makes 0, and 0 minus 6 is negative 6, and then this will be negative 6. Now I'm going to plug in a 2. 2 squared is 4, and then minus 2 makes 2, and then 2 minus 6 makes negative 4, and this will be negative 4. Now let's graph this. 1/2, negative 6 1/4. 1, 2, 3, 4, 5, 6, and an extra little bit. Then 0, negative 6 is right here, and 1, negative 6 is right here. Then we have negative 1, negative 4, and 2, negative 4. And now we can graph the curving branches. Number 7, let's graph another one. This is a quadratic equation because it goes to the second power. Is it in vertex form or standard form? This is standard form. The value of a is 1. The value of b is 5. The value of c is 4. Let's make an xy table. It's not really called y, it's called r of x, but you get the idea. Now in the middle row, we're going to do our vertex. And we're going to use the formula negative b over 2a to get this number for x. So this is going to be negative 5 over 2 times 1. That's negative 5/2. To get the y value of the vertex, we're going to use the formula c minus b squared over 4a. That's 4 minus 25 over 4. That makes negative 2 1/4. Knowing that I'm going to have to graph this point later on, I don't want to leave my x value as an improper fraction. I want it as a mixed number. So I'm going to remove the fraction and record that as negative 2 1/2. because I can find a dot for that. Now I'm going to choose something that's to the left of negative 2.5. I'm going to pick negative 3, then negative 4. To the right of negative 2.5 is negative 2, then negative 1. Now let's plug these numbers in and figure out what the answer is for y. Start by putting in negative 2. Negative 2 squared makes 4. And then right here, 5 times negative 2 is negative 10. So 4 minus 10 is negative 6. And negative 6 plus 4 is negative 2. And that'll be negative 2. Now let's fill in negative 1. Negative 1 squared makes 1. 5 times negative 1 is negative 5. And 1 minus 5 is negative 4. Negative 4 add 4 makes 0. And this will be 0. So let's graph these dots. Negative 2.5, comma, negative 2 and an extra quarter, about right there. Negative 3, comma, negative 2 is here, and negative 2, comma, negative 2 is here. Again, these dots have to be at the same level or we mess something up. Then negative 4, comma, 0 and negative 1, comma, 0. Now draw in the branches. You might notice when I drew the branches, I crossed the y-axis at 4. I did that because I knew that the y-intercept was a 4. Now number 9, another graph. Is it vertex form or standard form? This is standard form. A is 1, B is negative 4, and C is negative 1. Let's make an XY table. It's not actually called y, it's called g of x. Let's get our middle row first. To get the x coordinate, we're going to use the formula negative b over 2a. So that's going to be 4 over 2, which makes 2. To get the y value, we have a formula, or we can plug in 2. 2 squared is 4, 4 times 2 is 8, 4 minus 8 is negative 4, and negative 4 minus 1 is negative 5. Choosing numbers to the left of 2, it makes sense to use 1 and then to use 0. Choosing numbers to the right of 2, how about 3 and 4? Let's plug these in. 3 squared is 9, 4 times 3 is 12, and 9 minus 12 is negative 3. And then negative 3 subtract 1 is negative 4, and this is negative 4. Now let's fill in 4. 4 squared is 16, 4 times 4 is 16, and those subtract to make 0. And then when we minus 1, we get negative 1, and this is negative 1. So 2 comma negative 5 is the vertex. 1, 2, 3, 4, 5. We also have dots at 1 comma negative 4, and at 3 comma negative 4. And we have dots at 0 comma negative 1. And 4 comma negative 1. And draw in the branches. On page 235 orals, we have an equation. It goes to the second power, so it is quadratic. Is it standard form or vertex form? This looks more like the vertex form. If we fix the plus sign inside the parentheses and think of it as x minus negative 9 squared minus 1/3, now we have vertex form. We can see our value of a, we can see our value of h, and we can see our value of k. To get the equation of the axis, it's x equals h. So x equals negative 9. To get the vertex, it's h comma k. So it's negative 9 comma negative 1/3. Now we're asked if it has a minimum or maximum. To do that, you look at a. A is a negative number, so this has a maximum point. Then we are asked what is the maximum value of the function. That's the value of k, so that's negative 1/3. Number 15. We're told that a parabola has a point at 0, negative 4. We're also told the axis of symmetry is x equals -2. Let's get another point. Let's graph this. The axis of symmetry is at -2. So I'm going to draw a vertical line crossing the x-axis at -2. 0, -4 is on the graph. So 1, 2, 3, 4. That dot's on the graph. There's going to be a corresponding dot on the other side of the axis line, right there. Where's that dot located? It is -4, -4. Page 236, we're asked to graph these two parabolas. Well, what form do we have? Do we have vertex or standard form? Because knowing what form you have affects how you find the vertex. Here we have vertex form. This is H and this is K. On this one here, this is H and this is K. So let's make an XY table for both of them. Start with the middle row, the vertex. It's H, K. It's 1/2, 2. That is way faster than when you have standard form and you have to use formulas to get the vertex. Now to the left of a half is 0. To the left of that is -1. To the right of the half is 1 and then 2. Now let's plug these numbers in and see what this equation outputs. Start by filling in a 1. 1 minus a half is a half. A half squared is a fourth. -3 times a fourth is -3/4. And then when you add 2, you get 1 1/4. And this will be 1 1/4. Now let's fill in a 2. 2 minus a half is 3/2. 3/2 squared is 9/4. -3 times 9/4 is -27/4. And then we want to add 2. That makes -4 3/4. And this will be -4 3/4. Let's graph that parabola. 1/2, 2 is here. 0, 1 1/4 is here. 1, 1 1/4 is here. And -1, -4 3/4 is down here. 2, -4 3/4 is down here. And graph in the branches. Now I'm going to switch colors and make an XY table for my other equation. Let's fill in the vertex. Using H and K, it's 1/2, -2. Then choose other numbers for x and plug them in to figure out what y is equal to. Start by filling in 1. 1 minus a half is a half. 1/2 squared is 1/4. 3 times 1/4 is 3/4. And 3/4 minus 2 is -1 1/4. And this will be -1 1/4. Now let's fill in a 2. 2 minus a half is 3/2. 3/2 squared is 9/4. 3 times 9/4 is 27/4. And then 27/4 minus 2 makes 4 3/4. All right, let's graph these dots. 1/2, -2 is here. 0, -1 1/4 is here. And 1, -1/4 is here. -1, 4 3/4 is up here. And 2, 4 3/4 is up here. And graph in the branches. Notice the parabolas are reflections of each other over top of the x-axis. Next, number 7. Do we have standard form or vertex form? Or maybe neither? This time we don't have either of the forms. We almost have vertex form. But in vertex form, this is supposed to be x minus a number. It can't have a 2 in front of the x. So what we need to do is fix the form. I'm going to square the binomial. It will make 4x squared minus 4x plus 1. And then the plus 3/4. Next step, combine like terms. We have y equals 4x squared minus 4x plus 7/4. When I write the plus 7/4, I'm going to leave a little bit of space right here. Next, I want to factor a 4 out of this portion. That makes 4 times x squared minus x. I'm going to close the parenthesis and write the plus 7/4, but I'm keeping a little bit of space right in here. Next, I'm going to use the completing the square method that we had practiced in the other section. Take half of the -1. That makes -1/2. Then square the -1/2. That makes 1/4. Add a 1/4 into that blank spot. Now you can't just add a number to one side of the equation without compensating for it. When we wrote a 1/4 into the blank spot, what did we really change the right side of the equation by? Because there's a 4 out front, 4 times 1/4 is really a 1. By us writing a 1/4 here, we have really increased the right side by 1. So to compensate for it, let's minus a 1. Next step, let's factor our perfect square trinomial as x minus 1/2 squared. And then 7/4 minus 1 makes plus 3/4. What we've done is we've taken this original equation, which was not quite vertex form, and we've rewritten it so we do have vertex form. Now we have our h and our k and our a. To graph the parabola for that, we're going to make an xy table. The middle row of the table will be our vertex, which is 1/2, 3/4. Numbers to the left of 1/2 could be 0 and -1, and then use 1 and 2. Let's fill these numbers in to get the y values, starting with a 1. 1 minus 1/2 is 1/2. 1/2 squared is 1/4. 4 times 1/4 is 1, and 1 plus 3/4 is 1 and 3/4. And this will be 1 and 3/4. Now let's fill in a 2. 2 minus 1/2 is 3/2. 3/2 squared is 9/4. 4 times 9/4 is 9, and 9 plus 3/4 is 9 and 3/4. And this will be 9 and 3/4. Now we can graph that on the grid that we had up above. 1/2, 3/4 is located about right here. 1, 1 and 3/4 is here, and 0, 1 and 3/4 is here. And then 2, 9 and 3/4 is up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So right up at the top of the video screen. And a corresponding dot here. So here is that parabola. Now let's change colors and work on this other equation. Again, this is not quite the right format. So we need to use the completing the square process to fix this. First thing, let's square that binomial. It makes 4x squared plus 4x plus 1. And then on the end is plus 8/5. Next step, distribute this negative sign. We have negative 4x squared minus 4x minus 1 plus 8/5. Next step, factor out a -4. We have x squared minus x. Leave some space before writing the parenthesis, and combine the -1 and the plus 8/5. That makes plus 3/5. Then figure out what to fill in those parentheses. To do that, you take half of negative 1, which is negative a half, and then you square the negative a half, which makes 1/4. So in here I'm going to write plus 1/4. But by adding that number onto the right side of the equation, I've changed the value of the right side. By how much have I really changed the value? Because in front there's a negative 4 being times by that. So negative 4 times 1/4 is negative 1. By me writing 1/4, I really have changed the value by negative 1. I'm going to compensate by adding 1. Now I'm going to rewrite this in factored form. Negative 4 times x minus a half squared plus 8/5. This equation is vertex form. Now make the xy table that goes with that. The vertex is 1/2, comma 8/5. A number to the left of a half would be 0, then negative 1. And over here, how about 1 and 2? Now let's fill in 1. 1 minus a half is a half. 1/2 squared is 1/4. Negative 4 times a fourth is negative 1. And negative 1 plus 8/5 is 3/5. And this will be 3/5. Now let's fill in 2. 2 minus a half is 3/2. 3/2 squared is 9/4. Negative 4 times 9/4 is negative 9. And negative 9 plus 8/5 makes negative 7.4. And this is negative 7.4. Let's graph those points on our grid, starting with the 1/2, comma 8/5. 8/5 is the same as 1 and 3/5. So let's find 1/2, comma 1 and 3/5. Here's 1/2, and then 1 and 3/5 is about right here. Now let's find 1, comma 3/5. Maybe about right here. And 0, comma 3/5 is here. Now let's find 2, comma negative 7.4. 1, 2, 3, 4, 5, 6, 7, and an extra 0.4. And then there'll be a dot right here. Connect those together. Here's our two parabolas. Next, number 13. We have an equation for a parabola, but we don't know what h is. We are told that an answer for x is 0 and an answer for y is 5. Let's make the substitutions. 5 in for y, 0 in for x. Now let's solve this. 0 minus h is negative h. Negative h squared makes h squared, and then plus 1. Now subtract 1 from both sides. We get 4 equals h squared. Now take the positive and negative square root of 4. We're going to get two answers for h, positive 2 or negative 2. Number 19, determine all values r so that r, comma 0 is a solution. Remember, the first number parentheses is an x value. The second one's a y value. Let's make substitutions. For the letter y, fill in 0. For the letter x, fill in r. Now let's solve the equation. I'm going to add 3 to both sides. We get 3 equals 1/3 times r minus 2 squared. Then multiply by 3 on both sides. We get 9 equals r minus 2 squared. Then, to remove the squaring, take the square root. But remember to do the positive and negative square root. So we get positive or negative 3. And that's equal to r minus 2. Now add 2 to both sides. So we get r equals positive or negative 3 plus 2. And this is going to make two answers. Positive 3 plus 2 is 5. Negative 3 plus 2 is negative 1. Here are our answers for r.